Hello, this is MEI Further Maths Core Pure. We're in the second vectors section and on the third and final video on the angle between two planes. You can watch the video straight through, but you will probably find it helpful sometimes to pause the video and try things out for yourself before continuing to watch. Finding the angle between two planes could be quite tricky. You'd need to find the line of intersection of the planes, and then find a vector in each plane that was perpendicular to that line. Then you'd find the angle between those two vectors. Fortunately, there's a much easier way. The angle between the two normal vectors is the same as the angle between the two planes. The normal vectors are easy to find from the Cartesian equation of the planes. So we simply find those two vectors and work out the angle between them. Here's an example. I'm going to need both the normal vectors, so I'll start by writing those down. The first one is 2 minus 3, 1. And the second one is 5 minus 2 minus 4. I'm going to need their magnitudes, so I'll find those. The first one, root 2 squared plus 3 squared plus 1 squared, which is root 4 plus 9 plus 1, which is root 14. And the second one, root 5 squared plus 2 squared plus 4 squared, which is root 25 plus 4 plus 16, which is root 45. Now I can write down an equation. The scalar product of the two normals is equal to the product of their magnitudes and cos of the angle between them. So the scalar product is 10 plus 6 minus 4, and that's equal to root 14, root 45 cos theta, and therefore cos theta is equal to 12 over root 14 root 45. That's equal to 0.4781, and that gives us that theta is equal to 61.4 degrees. Here's another example. This time the equations of the planes are written in different forms. Pause the video while you have a go at working this out. OK, I start by writing down the normal vectors again. The first one read from the Cartesian equation, 2, 2, minus 5. The second one from the scalar product form of the equation is just that vector there that's dotted with the r. So n2 is 4 minus 3, 5. Again, I'm going to need their magnitudes, so I'll work those out. The first one, 2 squared plus 2 squared plus 5 squared, all square rooted. That's root 4 plus 4 plus 25, which is root 33. And the second one, root 4 squared plus 3 squared plus 5 squared, which is root 16 plus 9 plus 25, which is root 50. So I write down my equation. 2, 2 minus 5 dot 4 minus 3, 5 is equal to root 33, root 50 cos theta. Working out the dot product, I've got 8 minus 6 minus 25 equals root 33 root 50 cos theta, and therefore cos theta is equal to minus 23 over root 33 root 50. And that's equal to minus 0.5662. That gives me an angle of 124.5 degrees. However, I was asked to find the acute angle between the planes. What's happened is the normal vectors that I've chosen will be arranged like this, so that the angle I've found between the two lines where they're both going outwards, that's theta, which I've just found, but I actually want this angle here. So I simply subtract 124.5 from 180 degrees. So the acute angle required is 55.5 degrees. There are more notes on integral or in your textbook on the angle between two planes. That's the end of this short video and the end of this section.